Hi there Year 7, welcome to today's maths lesson. Let's start off with a quick starter for me. Can you work out 65 plus 86, 452 subtract 8.7, 4/5 divided by 7/9, 5.46 divided by 100, and can you find 2/7 of 28? If you finish all of those, have a go at my extension question. Can you put these values in order of size with the smallest first? Please pause the video for 5 minutes or so and have a go at these questions in your rough books for me. Okay, let's look at some answers. So a column addition for the first one will give you 151, and a column subtraction for the second one will give you 443.3. Now the third one, I need to apply my keep, flip, change policy. So I keep my first fraction, I flip my second one to 9/7, and then I change my sign so it becomes a multiply in the middle. 4 times 9 gives me 36, and 5 times 7 gives me 35 on the bottom. So altogether I've got 1 whole and 1/35. You could have left it as a mixed number or an improper fraction, both would be correct. For the next one, if I'm dividing by 100, I need to move all of those numbers 2 spaces in my place value table, and that gives me 0.0546. And to find 2/7 of 28, well, 1/7 I divide it by 7, and that gives me 4, so 2/7 would be 8. Now if you put these numbers in order of size, the little number, the indice, just tells me how many times I'm multiplying that number. For example, 3 squared is 3 times 3. Whereas 3 cubed is 3 times 3 times 3. We're multiplying it by itself 3 times. And if you did that, you'll find the smallest would be 3 squared, which is 9, all the way up to the largest, which was 3 cubed, which is 27. Well done if you got that right. Let's head into today's lesson. We're going to start with the diagnostic quiz. So these are A, B, C or D questions. Please write down your answers in your rough books and then I'll go through all the answers at the end. Question number 1, using your BIPs, what is 12 divided by 3 plus 1 times 5? Please pause the video if you need a little bit of extra time to work these out. Question number 2, if you're given that 6.5 times 8.2 is 53.3, what is 53.3 divided by 8.2? Again, pause the video if you need some time to work it out. Question number 3, what is 13 take away 4 take away 2 times 3? Again, pause the video if you need. Question number 4, what is -9 plus -4? Pause the video if you need. I recommend you model this using your algebra tiles. So think about how many reds you need for -9, how many you need for -4, and what happens when you put those together. And what is the area of this shape? I've given you a shape on a grid. What's the area? Okay, let's go through some answers. So question number 1, using my BIPs, my brackets, indices, products, and sums, the bit I need to do first is the products. So I've got 12 divided by 3 is 4, and 1 times 5 is 5. 4 plus 5 will give me A, 9. Question number 2, I can work backwards. I can say, well, if 6.5 times 8.2 is 53.3, 53.3 divided by 8.2 will give me A, 6.5. Question number 3, applying my BIPs, my brackets, indices, products and sums. I do my bracket first, 4 subtract 2 is 2. I then do my products, 2 times 3 is 6. Then I've got 13 take away 6, which gives me A, 7. Question number 4, -9 plus -4 will give you 13 red tiles altogether, so -13. And last question, the area of a triangle is given by half base times height, or base times height divided by 2. My base here is 3, my height is 2, so I've got 3 times 2 divided by 2, which gives me A, 3. Let's head into today's lesson. Now today we're going to consolidate all the work we've done on solving equations. We're going to start by looking at one-step equations. I'm going to model it. I'm going to say x plus 3 yellow squares is equal to -2, so 2 red squares. Now I want to know what the green rectangle is on its own, so I need to cancel out these 3 yellow squares. And to do that, I form 0 pairs, 3 of them. Whatever I do to one side, I do exactly the same to the other. And if each of these red squares is worth -1, what I've done is I've subtracted 3 from both sides. If I then remove my 0 pairs, I'm left with x, my green rectangle, is worth -5. Now sometimes you're going to be asked to solve an equation, and instead of x they're going to write another letter like a or y, but we solve them in the same way. It doesn't change anything, they've just substituted another letter in for x. I've got a, subtract 3, so 3 red squares, is equal to -2, 2 red squares. In the same way, I want just the green rectangle on one side, so to do that I'm going to add 3 yellow squares. And whatever I do to one side, I do exactly the same to the other. What I've done is I've added 3. If I then cancel out my 0 pairs, there's 3 0 pairs on this side, and there's 2 on this side. I'm left with a, my green rectangle, is equal to +1. Now for the last one, instead of x we've said y, but we're going to model it in the same way. 2 green rectangles is equal to 2 red squares. But I don't want to know what 2 green rectangles is worth. I want to know what 1 is worth, so I'm going to share them out. And what I've done is I've divided by 2. So y is equal to -1, or 1 green rectangle is equal to 1 red square. And I look at one more type of example. Now this time I'm given +3, subtract x, so a red rectangle, is equal to -2, 2 red squares. Now I don't want a red rectangle, that makes my life difficult. But I can cancel that out by adding a green rectangle. Whatever I do to one side, I do the same to the other. The green rectangle is worth +x, so all I've done is I've added on x. If I then remove my 0 pair, what I'm left with is +3 is equal to x subtract 2. And now it looks really similar to all the ones we've been solving before. I add 2 yellow squares to cancel out the 2 red squares. Whatever I do to one side, I do exactly the same to the other. If I then cancel out my 0 pairs, I've added 2, and x, my green rectangle, is worth +5. Over to you guys. In your rough books, please pause the video for a minute or two and work out this one in the same way. If you need to rewind and watch my example, that's fine too. Okay, let's go through it. I've got 2, subtract x, a red rectangle, is equal to +3. I don't want a red rectangle, I want a green one. I want to know what +x is worth. So I'm going to add a green rectangle to both sides. And what I've done is I've added on x. If I remove my 0 pair, that tells me 2 is equal to +x plus 3. Now let's solve it in the usual way. We'll add 3 red squares to cancel out these 3 yellows. Whatever I do to one side, I do exactly the same to the other. Adding 3 red squares is the same as subtracting 3. And if I then cancel out my 0 pairs, my x, my green rectangle, is equal to -1. Over to you guys. In your rough books, please pause the video for 10 minutes and have a go at as many of these questions as you can. Pause the video now. And these are the answers. Please check your work and see how you did. Okay, we then moved on to looking at two-step equations, and we're going to begin them in the same way by modelling them using the algebra tiles. So I've got 2x plus 1 is equal to -3. We don't want to know what two green rectangles and a yellow square is worth. We want just the green rectangles on one side of the equation. So I'm going to add a red square to cancel out that yellow one. And whatever I do to one side, I do the same to the other. A red square is worth -1. So what I've done is I've subtracted 1 from both sides. If I then cancel out my 0 pair, I'm left with 2x is equal to -4. But I don't want to know what 2x is worth. I want to know what 1x is worth. So I'm going to divide those up and share them equally. And I've divided it by 2. Which tells me x is worth -2. For my next example, I've got a p instead of an x, but I'm going to treat it in the same way. 3p, or 3 green rectangles, subtract 1 red square, is equal to +5. I've got a mixture of rectangles and squares, so I need to cancel out that red square. And I do that by adding a yellow to make a 0 pair. Whatever I do to one side, I do the same to the other. The yellow square is worth +1. If I remove my 0 pair, I'm left with 3p, or 3 green rectangles, is equal to +6. But I don't want to know what 3 green rectangles are worth, I want to know what one of them is worth. So I need to share out my squares equally. Each of those green rectangles is worth +2, and what I've done is I've divided it by 3. P is worth 2. Over to you guys. In your rough books or on your mini whiteboards, whatever you have to hand, please pause the video for 10 minutes or so and solve each of these equations. The solutions are in the grid somewhere. So you see if you can find your answers in the grid and solve those equations. You'll be left with 5 numbers in the grid, and if you add those up, that will give you a total. So pause the video for 10 minutes now. And if you did complete all of those equations and added up your final answers that were left over in the grid, put them in these squares at the bottom, your total would have been 0. Well done if you got that right. We've got one final type of example to look at. This is when we've got unknowns on both sides of the equation. So I've got an x on this side of the equals and this side. I'm going to start by modelling it. So 2x plus 1 is equal to 2 plus x. Now this time, I'm going to start by getting rid of the green rectangle on the side where there are less green rectangles. On this side there's only 1, on this side there's 2. So to cancel out that green rectangle, I'm going to add a red rectangle. Whatever I do to one side, I do the same to the other. The red rectangle is worth -x, so what I've done is I've subtracted x from both sides. If I remove my 0 pairs, what I'm left with is 1x plus 1 is equal to 2. Now I can solve this as I normally would. I want to get rid of that yellow square. To do that, I add a red square. I do the same to the other side. The red square is worth -1, so I've subtracted 1 from both sides. If I remove my 0 pairs, there's 1. There's another. X, my green rectangle, is worth +1. For my next example, I've got to start with 3 x's, so 3 green rectangles. Subtract 1, a red square, is equal to -3, 3 red squares, plus x, a green rectangle. Again, I want to remove the x from the side where there are less of them. There's only 1 x on this side and there's 3 on the other. I want to remove this green rectangle. And to do that, I'm going to add a red one. A red one is worth -x, so what I've done is I've subtracted x from both sides. If I then remove my 0 pair, there's 1. There's another. I'm left with 2 lots of x. Subtract 1 is equal to -3. Now I've got a mixture of green rectangles and squares on one side, so I need to cancel out that 1 square. And to do that, I'm going to add a yellow square to form my 0 pair. Whatever I do to one side, I do the same to the other. It's a yellow square, so I've added 1. If I remove my 0 pairs, I'm left with 2x is equal to -2. But I don't want to know what 2 green rectangles are worth. I want to know what 1 is worth, so I'm going to split those up and share them out. 1 green rectangle x is worth -1. I've divided it by 2. Over to you guys. In your rough books, please pause the video for 10 minutes or so and have a go at these questions, please. And these are the answers I was looking for. Please check your work and see how you did. Okay guys, if you have any time left in the lesson, please pause the video for 5 minutes or so and have a go at these. Now I've given you the equation for one of them. I want you to draw me the model and find the solution. For the second one I've given you the model. Can you write me the equation and find the solution? For the third one I've given you the equation but not the model or the solution. For the fourth one, I've given you the model but not the equation. Can you work backwards? And for the last one, I've given you the equation. Can you model it and find me the solution? If you finish all of those, can you make up 5 equations of your own where the solution is x is 1? Please pause the video if you have time and spend 5 minutes on this now, please. And these are the answers I was looking for. Please check your work and see how you did. If you were looking for equations where x was equal to 1, these are the ones I came up with. These were some 1-step equations, some 2-step equations, and some where the unknown was on both sides. There are lots of possible examples. Yours were probably better than mine. And that's the end of today's lesson. Please head on over to Google Classroom and submit today's exit ticket so I can assess your learning for today. Thanks very much for listening and have a wonderful day. Off you go. Goodbye.